Hello, welcome to your Day 2 notes of our trig graphing unit. Today we're going to talk about period and frequency of a trig graph. So yesterday we talked about the basics of sine and cosine and discussed what the A as the leading coefficient represents, which is the amplitude or the height from the midline of the graph. So we'll go ahead and fill that in. A is amplitude. Now I've added a new letter today, B, which is going to represent the frequency of the graph. Okay? Now, frequency represents the number of complete cycles from 0 to 2 pi, or I like to say over 2 pi units. So I'll add that over here. Okay, now keep in mind that one cycle of sine looks like this. Starts on the midline. You get a max and a min. So that's one cycle of sine. One cycle of cosine starts off the midline, dips below, and then finishes above the midline where you started. Okay, so one full cycle of sine looks like an S. One full cycle of cosine kind of looks like a C. All right. Now, how does this relate to period? Well, the period is the horizontal distance of one full cycle. So it's how much space you would need in order to see one full curve. So yesterday, we graphed sine and cosine over the interval of 0 to 2 pi. So I'll add that up here on my little sketches, which means the frequency is 1 because you're seeing one full cycle over 2 pi units, and the period would be 2 pi. Now we can compute the period of any graph by using the formula period equals 2 pi divided by the frequency. Okay, so for instance up here on these little sketches I came up with, the frequency is 1 of each of those, because again, you're seeing one full cycle over 2 pi units. And the period of each graph would be 2 pi. Oops, I got messed up. Would be 2 pi, because if you do 2 pi divided by the frequency, aka 1, you would get 2 pi. Okay, same thing over here. I'll just kind of scooch this in here. Period equals 2 pi. Okay. Another way to think about this, guys, is if you looked at the distance between two consecutive maximums, that would also represent the period. So if this were to continue, continue again, the distance between the maxes would be equivalent to 2 pi, which again would be the period. But I mostly just look at it. I look for, let's say, the S shape, and I'm like, okay, how long did it take me to see that? Oh, it took me 2 pi units. That's the period. So in the table below, I'm going to switch up the frequency on you guys. So you'll notice we start with our basic y equals sine of x, and then I change it to a 2, a 3, a 4, and a 1/2. Okay, now I'm also going to graph a couple of them down below on this grid, so you guys get a visual representation of what's happening. Okay, now at the top here, okay, I have everything labeled for you. Our equation, our frequency, which again is how many full cycles you would see over 2 pi units, what the period would be, which is how much space you would need along the x-axis to see one full cycle, and how many boxes that would be. So keep in mind, guys, that when I have you set up your x-axis, I always say, okay, every 3 boxes is pi over 2 or 90 degrees. So if every box, or every 3 boxes is pi over 2 or 90 degrees, keep in mind that every 1 box would be 30. And we'll use that to adjust how we would graph our trig functions when I change the frequency. All right, so starting with our basic, y equals sine of x. Because the b value, which is right in there, is nothing listed, it's a 1, that means the frequency is 1. So over 2 pi units, you would see one full cycle of sine. The period would be equivalent to 2 pi over 1, which is just 2 pi. Okay, so if we were to see one full cycle of this trig function, so one whole period, that would be 2 pi or 360 degrees. That would take us 12 boxes. Now I'm figuring that out because I'm like, okay, if every one box is 30 degrees, times 12 would be 360 degrees. So times 12 again, and there you have it. And I'm going to go ahead and graph this below because this is exactly what we've been doing. Okay, so on the grid below, I'm going to zoom in here because I'm on a tablet. Okay, every 3 boxes is pi over 2. Okay, amplitude is 1, so I'll do 2 boxes equals 1, so it's not tiny. Okay, so what we're saying here is one full cycle fits between 0 and 2 pi or 360 degrees. So sine starts on the midline, so it would end on the midline. Halfway in between, it would hit the midline again. Halfway it goes up. Halfway it goes down. And so what I've just graphed in green is just your traditional y equals sine of x. Okay, so guys, as you're doing these notes, I might recommend that you do color code like me so that you can keep track of what's what. Okay, so this is nothing new. This is the usual. According to my little boxes and everything, like I said, every one box is 30 degrees. So if I need 360 degrees, I would need 12 boxes, which is what you guys are seeing. 3, 6, 9, 12 boxes is one period. Okay, so this right here is representing our period, which is 2 pi units, because the frequency is 1. Okay. Let's switch it up now. Okay, so now I'm going to make the frequency be 2 because I put a little 2 here. That means the period is 2 pi over 2, which is pi units. Okay, so pi units is the same thing as 180 degrees, right? So that means if I want to see one full cycle of this y equals sine of 2x, I would need 6 total boxes, right? Because in order to get from 30 degrees to 180, I'd multiply by 6. So that means 1 times 6 is 6. Okay, so I'm going to come on down to the same grid. And I'm going to change my color here. Let's use pink. Okay, so what I just told you guys is you're going to see one full cycle of sine in pi units. Okay, so that's going to be in 6 boxes. All right, so if I zoom in here, that means, again, sine starts on the midline, so we're starting here, ending here. Notice how that's 6 boxes. Halfway, it's on the midline. Halfway, we go up to our max, so I'm right in the middle at 1.5. And halfway, I'm at a minimum. And then I'll go ahead and label that. Y equals sine of 2x. Now, the reason why the frequency is 2 is because if I were to continue this pattern, I would see 2 full cycles of sine. So for sake of argument, guys, let's go ahead and do that. So start here, end here, halfway in between. Again, this is another 6 boxes. Halfway, I'm up at the max. Halfway, I'm down at the min. Okay, and that's why the frequency is 2. You are seeing 2 full cycles over 2 pi units. Okay, the period is pi units because that's how long it's taking you to see that one full cycle. All right, so you'll see it got like shrunk up a little bit. You can fit more sine curves into pi units. All right, let's go to the next guy. Okay, now I've changed the frequency to 3. Okay, so that means the period is 2 pi over 3, which is not super obvious what that would be. Okay, I'm going to grab my calculator real quick. Okay, there he is. And I'm going to convert this. So this would be 2 times 180 divided by 3. And that's 120 degrees. Okay, so that means that's how long it would take you to see one full cycle of this y equals sine of 3x. Now, if one box is 30 degrees, that means I would need 4 total boxes to see one period of this. I can fit one more on this. I'm going to zoom in. I'll do some blue color. Okay, so over 4 boxes, you're going to see one period, right? So here's the beginning. 1, 2, 3, 4. There's the ending. Halfway, I'd be on the midline again. Halfway, I'm up at 1. Halfway, I'm down at -1. And there you go. And if I were to continue that pattern, guys, you would see a total of 3 of those curves because it's y equals sine of 3x. So I'll add a little label again. Okay, so for sake of argument, let me continue this. So 1, 2, 3, 4, that would be the ending. Halfway, halfway, halfway. And then 1, 2, 3, 4, halfway, halfway, halfway. And there you have it. Okay. Oh, one more thing I'll say. Again, keep in mind with this graph, the frequency is 3. The period is 2 pi over 3, which is actually what this little tick mark is right here. Okay? Because when you think about it, pi over 3 is 60 degrees, so it's 2 of the 60 degrees, which is why it's 2 pi over 3. 4 total boxes. All right, that graph is getting kind of hectic. All right, coming on over to the next guy. Sorry, my thing is just like, it's like jumping on me. Okay, there we go. All right, so now sine of 4x. So this would have a frequency of 4 and a period of 2 pi over 4 or pi over 2, which as we know is 90 degrees. So I put the 90 here, which means if one box is 30 degrees, that means I would need 3 boxes to see one full cycle of that. Okay, I'm not going to do that one. You just have to do the same thing, beginning, end, halfway, halfway, halfway. The last one I will do, okay, y equals sine of 1/2x. So this one's interesting. If you do 2 pi divided by 1/2, that's the same thing as 2 pi times 2, or 4 pi. So guys, if 2 pi is 360 degrees, then 4 pi is 720 degrees. Okay, now if you're trying to figure out how many boxes you would need, okay, 720 divided by 30, because each box is 30 degrees, is 24. So that means you would need 24 boxes in order to see this full cycle. Okay, now I'm actually going to only do half of it just to show you what this looks like, okay, because I only have mapped out enough here on this grid on the right. So let me zoom in here. And you'll see what I mean once I get into this. So every 3 boxes is pi over 2. Okay. There's 2 pi, which is 360 degrees. Okay, and I'll label this as 1. This is -1. Okay, so basically, guys, this is what's happening. This is one full sine curve, right? But this is where 4 pi will be in this last scenario because that'll be one period, which means that halfway in between is 2 pi, which is how much I'm going to fit on this grid. Okay, so that means we're starting on the midline, which would be right here. This would be that halfway point because technically there would be another point off the grid to the right. and then halfway between 0 and 2 pi would be that maximum right there. So the reason I'm only seeing half of the sine curve is because the frequency is 1/2. I'm actually going to redo this curve. I don't like how that looks. That looks a little bit better. All right, so I'm going to go ahead and label this y equals sine of 1/2 x. And again, if I were to continue this, so obviously there's not enough space here, but if I were to continue this, it would look like that. It would end at 4 pi, and there'd be a minimum right there, okay? But this is how much I'm fitting here, okay? So this guy has a frequency of 1/2 and a period of 4 pi. All right, so that's our whole table. All right, so moving to the next page, we're going to do some examples where I throw some amplitude in there as well. Okay, so graph y equals 3 sine of 2x on the grid below for the interval of 0 to 2 pi. All right, so based on this equation, I know the amplitude is 3, the frequency is 2, which means the period is pi units. So again, I'm just doing, guys, 2 pi divided by the frequency to figure out the period. So keep in mind, that means over pi units, you're going to see 1 full cycle of sine. All right, so let's set up our axes. I'm going to zoom in a little bit because, again, I'm on a tablet, so it's a little bit harder to do. So 1, 2, 3. Every 3 boxes is pi over 2. Okay, and I know I need to go to 3 for my amplitude, so just make sure we're labeling. Okay, so sine starts on the midline and ends on the midline. So notice this is the start and end, and I put it at pi because that's the period. Halfway in between, you'd be on the midline again. Halfway we go up to a max, halfway we go down to a min, and we just connect the dots. And there you go. That's 1 full cycle. So I'm just going to repeat that one more time because it wants me to go from 0 to 2 pi. So that's beginning of the next cycle, end, halfway, halfway, halfway. Oops. And there you have it. Make sure your curves on this are kind of nice. Don't make them too pointy, and also don't make them like shark or what do I want to say? So basically, don't do this. Don't have like shark teeth where it looks like a cardiograph, and don't make them so super bubbly where now this is vertical and now it's no longer a function. So you got to find that sweet spot in between. Now, when we talk about the domain, we'll assume this goes on forever. Okay, so our domain will have no restrictions. That's just going to be all reals. Our range, though, is from -3 to 3. Now, how many curves for the graph above would you expect to see on the interval of 6 pi to 7 pi? So, like, if you were to continue this pattern out forever, look at 6 pi to 7 pi, how many cycles would you see? Well, 6 pi to 7 pi is a difference of pi units. You know the period is pi units. So if the period is pi units, we know that we would see 1 full cycle, or 1 full curve, sometimes we'll say, over that interval of 6 pi to 7 pi. And again, that's because the difference between 6 pi and 7 pi is only pi units, so I can expect to see 1 full cycle. The equation of the midline here, guys, is just the y-axis, or excuse me, x-axis. We haven't done anything yet. Eventually, we'll start shifting stuff up and down, but for right now, we'll keep it relatively unexciting right now at y equals 0. Okay. Next example, graph y equals 2 cos of 1/2 x. So the amplitude would be 2, the frequency is 1/2, which means the period is 2 pi divided by 1/2, or 4 pi. Now you'll notice, guys, that we're only graphing on the interval of 0 to 2 pi, so keep in mind this is what cosine looks like, right? So they're saying One full cycle of cosine would end at 4 pi units, but we're only graphing to 2 pi. So you're only going to see half of the curve, which makes sense because the frequency is 1/2. Okay, let's set up our axes. Okay, amplitudes 2. So if I look at this little sketch I did off to the right, you're only going to see the beginning, the end, or, well, I should say the beginning and the minimum, which is your halfway point, and then halfway in between that. Okay, so I have a maximum here at 2. We're starting above the midline. After 2 pi units, we're going to end below the midline, and halfway, we're at pi. Now, do not do a straight line here, guys, because this is a cosine curve, so give it a little bit of sass. A little bit of curve to it. And that's your graph. Our domain is all reals. If this were continuing on forever, our range would be -2 to 2. Now, if we were to look over the interval of -2 pi to 2 pi, how many cycles would we expect to see? Well, let me actually graph this down here. This is where -2 pi would be, and this is where 2 pi would be. This is 2 pi units away from 0. This is also 2 pi units away from 0. So this is a total of 4 pi units. So guys, they're asking you to look over the course of 4 pi units. Well, you know the period is 4 pi. So with that being the case, we would expect to see 1 full cycle over those 4 pi units. Just like last time, the midline is nothing too fancy right now. It's just the x-axis, or y equals 0. All right, we'll go ahead and flip. Okay, we got 2 more examples here. Kind of 3, because the last one's a double whammy. Graph y equals 2 sine of 3x. All right, amplitude is 2, frequency is 3, which means the period is 2 pi over 3, or 120 degrees, because we did that one in our table. Okay, this is 2, this is -2, and then set up our axes. Okay, so keep in mind, as mentioned before, if every one box is 30 degrees, and I need to map out 120 degrees to get 1 full cycle, I would need 4 boxes to do that. So, here's the beginning, 1, 2, 3, 4, here's the end. Halfway, we're on the midline again. Halfway, halfway. Here is, oops, I don't like that curve. Here is 1 full cycle. Now, I have to repeat that 4 times, well actually 3 more times, so 4 total times in order to go over 0 to 2 pi. Okay, so here we go again. Beginning, 4 units later, end, halfway, halfway, halfway. Okay, beginning, end, halfway, 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 and done. And that's y equals 2 sine of 3x. Our domain is all reals. Our range is -2 to 2. Okay. How many full curves would we expect to see over -2 pi to 2 pi? All right, so just like I said before, this is -2 pi, this is 2 pi. So that means this is 2 pi units, this is 2 pi units, so we're looking over the course of 4 pi units. Now this one's a little bit more thoughtful, or more thought-provoking. Okay, we're asking you to look over 4 pi units. Okay, now 4 pi units is the same thing as 720 degrees, if you want to think about it that way. Okay, now you know that the period is 120 degrees. So if I do 720 degrees by 120, let's see what we get. 6. So that means I would expect to see 6 full cycles of the sine curve over that interval of negative 2 pi to 2 pi. Okay, because again, I took the period, or I took the interval and I divided it by the period. All right, what's the equation in the midline? Still y equals 0, nothing too crazy right now. All right, last one, we're gonna do a double whammy. On the same set of axes, we're gonna graph y equals negative 4 cos of 2x and y equals 2 sine of 1/2 x on the interval of negative 2 pi to 2 pi. All right, let's set up our axes. Okay, and I know the amplitude for the first guy is going to be 4, so I'm just going to mark that off for myself. So 4, negative 4. All right, I'm going to do pink for this first guy. All right, so just like before, let's talk about the ABCs of this. A would be negative 4, that's your amplitude. B is 2, that's your frequency, which means the period is 2 pi over 2, or pi units. Okay? So that means over pi units, we're going to see one cosine curve. Now, pay attention to that negative in front as well. So normally cosine would start above the midline here at 4, but we're actually going to start down here at negative 4, which means pi units later will end in that same place because it's cyclic. Halfway in between, we've got to oscillate above the midline. And then halfway, we're on the midline. And that is one cycle of cosine. And now I just have to repeat that 3 more times to fill out this interval. Okay, and in the negative direction. And I'll label. Now see why this makes sense that it has a frequency of 2. If you look over 2 pi units, you are seeing 2 full cycles of cosine. All right, next, let's do blue for this guy. Okay, A is 2, B is 1/2, which means the period is 2 pi over 1/2, or 4 pi. Okay, so guys, if we're graphing, let's say from 0 to 2 pi, that means you're only going to see half of this sine curve. So you're only going to see that portion of it. Okay, so that means you start on the midline right there. You're going to see this little intersection point on the midline at 2, because 4 pi would be way over here, and then halfway in between, you're at a max of 2. And there you go. So that's all you're going to see from 0 to 2 pi. Now, keep in mind that you're going in the negative direction as well. So you're still going to hit the x-axis at negative 2 pi, and then halfway in between, at negative pi, you're down at negative 2. And there you have it. Now, here's why this makes sense with our frequency. Look at this. This is 4 pi units worth of graph. I am seeing one full sine curve, which is one full S, over 4 pi units, which is why the period is 4 pi. Okay? Now, one last follow-up question here, guys. It asks for how many times do these graphs equal each other on the interval of negative pi to pi? Okay, well, negative pi is here. Pi is here. Okay, so if I'm looking on that interval, I'm really just looking at how many times they intersect. So I see 1, 2, 3, 4 total times. So that's our answer. Oh, I probably should have labeled this guy as well. I meant to label him. All right, y equals 2 sine 1/2 x. All right, so hopefully that made sense to you guys. Feel free, obviously, to rewatch as much as you need, and let me know if you have any questions. Good luck.